Happy Friday, third graders. This is Miss Fiddler here to teach you guys your math lesson for the day. Hope you guys are all doing well. Just like we've been doing with all of our other math lessons, we're going to start off with a couple warm-up problems. So I want you to, after I read through them, I want you to pause the video and take a moment to answer them. So the first thing I want you to do is identify these two different quadrilaterals that I have here. So identify what this one is and then what this one is, and then I want you to list two similarities, so two things they have in common, and then list two differences they have, and be really specific when you're giving your differences. Don't just say like a word like angles, like explain to me how they're different, how the angles are different, okay? And then we have a story problem. Emery was making dessert for his party. He made 9 dozen chocolate chip cookies, 4 dozen blueberry pies, and 8 dozen brownies. How many desserts did he make in all? Once you are done answering those questions, you can unpause the video and we'll keep going. All right. So before we dive into our perimeter and area lesson for the day, I actually wanted to go back and take a look at some of the riddles that you guys wrote. So earlier this week when I did my other lesson, we walked through the steps on how to make those quadrilateral riddles for the different quadrilaterals that we were using in our lessons on that you did with Mrs. Amy on Monday. So what I did was I asked each of the teachers to send me one riddle from their students. So yours may not be in here, but then as we continue out through the rest of this unit, our morning work, those questions that we answer at the beginning of everyone, we might have a riddle in there. So I have 5 riddles that we're going to go through. Now, if you still have those quadrilateral pieces at home, you can grab those and maybe do the riddle along with me and see if we end up in the same spot. Otherwise, you can just watch and try to think, and as I'm sorting through my quadrilaterals, what you think it might be. All right, so our first riddle we're going to look at today is from my class. So Brennan from my class wrote this following riddle. So I'm going to show it to us, show it to you one clue at a time, and then we will, and I'm going to have to keep bringing it up, but I'm going to go back and forth between my quadrilateral pictures here. I know they're kind of tiny, but just so that we can see the clue and the pieces at the same time. All right. So his first clue he gave us was that his quadrilateral has 2 pairs of parallel lines. So if I look at all of these quadrilaterals, I know that squares have 2 pairs of parallel lines. So I'm going to bring all the squares down. And let's see, if I go shape by shape, trapezoids, nope, they only have 1. Okay, rhombuses have 2. Rectangle, no, yes, 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 no, 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 and no. So the ones on the bottom here are all the shapes that we have that have 2 pairs of parallel lines. So it's either going to be a square, a rhombus, or a parallelogram. All right, let's see what his next clue is. It's wider than how tall it is. So it's wider than the tall. So let's see, this square, nope, I don't think it's giving any of the squares because their height and their width are exactly the same. Okay, this one's wider than it is tall. This one's wider. This one's wider. Oh, this one's taller, so not that one. And this one. Okay, so I'm down to the rhombus, 1 of the rectangles, and the 2 of the parallelograms. All right, let's see what we got next. It has 2 acute angles. Ooh, rectangles only have right angles. Okay, this one has 1, 2, 1, 2, 1. Okay, I got rid of 1 more. Okay, let's see if this last clue can help us choose which one it is out of these 3. It has 4 sides that are congruent. Well, I know that in rhombuses have to have 4 equal sides, and I can tell in these parallelograms their width is longer than their height. And I know I might be saying, well, Miss Fiddler, but you just said in clue number 2, it's wider than it is tall. And that's true, but I think because this rhombus, the way that the lines are angled, it makes it overall wider than it is tall. So am I right? Is it rhombus A? Yes, I got it. All right, so that was the riddle from my class. All right, let's see. Next we have Keegan from Mrs. Kelly's class. We have his riddle to solve. So let's see what we can do. His first clue says, My shape has no right angles. All right, let's see. Okay, so I'm looking for anything without right angles. That trapezoid A has one. All right, that one doesn't have any. I'm not quite sure quadrilateral A does, so I'm gonna bring it down anyways. We can check it later. No right angles. No right angles. No right angles. Oh, that's a right angle right there, kind of like that check mark. Oh, it could be this one. Most definitely not a square. Squares and rectangles have right angles, so it is most definitely not those. All right, I've sorted them out. So all of these up here have right angles. All of these down here don't. Let's see what a second clue is. My shape has no parallel sides. Okay, well, that doesn't have any parallel. No, okay, I can keep these. Oh, this one has parallel lines, so it's not this one. This has one pair. No. Oh, and I got to get rid of the parallelograms. All right, so I'm left with the just the basic quadrilaterals. Again, I hope I'm doing this right. My shape has two sets of congruent sides. Two sets of congruent sides, meaning that there's two different pairs of congruent sides. So I can tell on quadrilateral D, there's no congruent sides. So I'm going to get rid of that one. And same with quadrilateral C. But if I look at A, this line and this line are congruent. So there's one pair. And this line and this line are congruent. So it could be quadrilateral A, or it could be B, because this longer side is congruent to this longer side, and the two shorter sides are congruent. All right, let's see if Keegan's last clue can help me figure out which one it is. My shape has 3 obtuse angles and 1 acute angle. All right. Well, if I look at quadrilateral A, I see 3 acute angles, but this angle right here, this is actually not what we call an obtuse angle. It's actually something called a reflex angle. When it goes past the straight line, when it kind of looks like it's bending over backwards, it's called a reflex angle. So I think it's quadrilateral B because I'm seeing 1, 2, 3 acute angles and 1 obtuse angle. All right, let's see if I'm right. Quadrilateral B. Yes, I got it. That was a great riddle, Keegan. Good job. All right, riddle number 3. This is from McKenzie in Mr. Gobler's class. All right, let's see what we got. I have 2 sides that will never touch. Now, based off of that, it sounds like she's talking about parallel lines, because I know parallel lines will never touch each other. And it says I have 2 sides, so I'm assuming that's 1 pair. So I know trapezoids have 1 pair of parallel lines. Now let's see, no parallel, these are all have 2. 2, 2, 2, 2, none, 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 none. Okay, so I've already narrowed it down to being one of these trapezoids. Let's see what other attributes she was mentioning. I have 4 sides. Okay, they all have 4 sides. One of my sides goes down a hill. I think she's describing, maybe it's more, the line is more at a slant. So all the lines on here are straight, but there's kind of these slants going on. So in trapezoid A, we have 1 line going at a slant, or a diagonal, we could say. And trapezoid B, we have 2. So since she's saying a hill, I think she means 1. So I'm going to get rid of trapezoid B. All right, I'm going to look at the last attribute and see if it matches trapezoid A. I have 2 right angles. Does trapezoid A have 2 right angles? It most definitely does. Is it trapezoid A? Yes, I got it right. All right, that was another great riddle, McKenzie. All right, next. All right, we have 2 more. We have Mrs. Avy's class next, I believe. All right, in Mrs. Avy's class, I have Morgan's riddle. So let's see what she came up with. Her shape has 2 pairs of parallel lines. So let's see, I'm going to go pull down all the squares and the rectangles and the rhombus and the parallelogram. They all have 2 pairs. All right, let's see what's next. 4 right angles. 4 right angles. Yes. Oh, I'm just going to get rid of the parallelograms and the rhombus. All right, let's see what we got next. 4 congruent sides. Ooh, All right, remember congruent sides mean they're all equal. So I'm going to get rid of the rectangles because these sides, we have two different types of length sides. All right, so I know it's going to be one of the squares. So Morgan, let's see if your last clue will help me figure out which square I'm going to be pointing out. It is small. All right, well, going with the different sizes, square B is the smallest. So let's see if it's square B. Yes, it was. Great, Riddle Morgan. All right, we have one more riddle to do. And this is from Austin in Mrs. Gross class. All right, his first clue. My shape has two pairs of parallel lines. Oh, just kind of like Morgan started off that way. So let me bring all of these back down. Okay, let's look at a second clue. My shape has two obtuse angles. So remember, obtuse angles mean they're really wide angles. All right, rhombus A, yep, this angle and this angle are both obtuse. Rectangle B, only right angle, so it's not going to be that. Parallelogram A, oh, there's an obtuse angle and there's an obtuse angle. Parallelogram B, oh, there's an obtuse angle and a second obtuse. Rectangle A, oh, only right angles, so it's not that. And squares only have right angles, so it's not going to be any of the squares. So it's either going to be a parallelogram or the rhombus. All right, let's look at clue number 3. My shape doesn't have equal sides, so they're not congruent. Oh, well, I guess the rhombus has to go because a rhombus has 4 equal congruent sides. All right, so one of the parallelograms, let's figure out which one it is. My shape is about 1 centimeter tall. Oh, Austin, you're making this tricky for me. I don't have a ruler handy and it's on my computer. Well, based on what I know about centimeters, they aren't very big. So I'm going to go with parallelogram A because it's a bit on the shorter side. All right, let's see. Am I right? Yes, I am. All right, you guys all created such awesome riddles. And like I said before, we're going to be, your teachers might be sharing some other riddles as we go through our morning warm-up problems. And so maybe your riddle, if it hasn't been shown, will be shown by someone else. All right, we're going to dive into the rest of our lesson today, and we're going to continue talking about perimeter today. Now, yesterday, I know Mrs. Avey read you the book, or you watched a video about the book of the 329th Friend, about Emery and his party, and then you were using kind of the idea of that book to help you find the perimeter of different tables that Emery could use at his party. Now, yesterday, you were creating tables that could seat 10 people. Today, I'm going to ask you to do something similar, but today you're going to use tiles to make tables that can seat 20 friends. All right, so just like yesterday, we are going to use the pattern shapes website that you guys were using there. We're just going to use the squares again. Okay, now, I'm going to ask you guys to, in a moment, to pause the video, and I want you to try to come up with some different combinations of chairs, different combinations of tables that could seat 20 people. Now remember, one side of the table is going to seat one person. So like this square right here, this would be one person, a second person, a third, and a fourth. So remember, the perimeter of this table is 4 people or 4 animals. Okay, so we're only fitting one person on a side. So remember, your perimeter is going to be 20. Please remember that perimeter is different than area. Okay, so like yesterday when you were doing some different combinations with Mrs. Avey, like she was showing you maybe a combination like this, and this had a perimeter of 10 because it was 1, 2, 3, 4, 5, 6, 7. Oh, I'm sorry, 8. I'm incorrect there. Let me move this. So that would be 8 people. And then this would be 10. So the perimeter of this is 10. But the area is something completely different. The area is only made up of 4 tables. So we have 1, 2, 3, 4 tables there. So the area, remember, is the space inside of something. The perimeter goes around the outside. So while you're creating your different tables that could make space for 20 friends, you're going to be using different amounts of tiles. You might be using a lot of tiles, you might just be using a couple. Okay. Another thing I want you to keep in mind is today we're only going to be making tables that are different rectangles. I know yesterday with Mrs. Avey, she was showing you some different combinations where like maybe you could have a table that looked like this to seat 10 people, but that's not a perfect rectangle. Okay, that's like if we count the sides, we have 1, 2, 3, 4, 5, 6, 7, 8. This is actually an octagon because there's 8 sides to it. We're only going to be dealing with rectangles, so quadrilateral, so there should only be 4 sides. Basically, you're going to be making some different arrays. Okay, now on this website, once again, I want you to be pulling out different tiles, and if you really want to play around with it, you can even change the colors of them, but don't waste too much time doing that. I want you to try to see if you can come up with 3 different arrangements for seating 20 people. They might all include different amounts of tiles. Okay, so some, like I said a moment ago, some of your tables might only use, I don't know, a couple tiles, and maybe you come up with a rectangle that has a lot. But remember, the perimeter is only going to be 20 people can sit around it. So I want you to pause the video and try to come up with 3 different combinations. Okay, go ahead. All right, now hopefully you have 3 different combinations on your display. Now just to kind of speed things up a little bit so you don't have to sit here watching me pull out different tiles, I'm actually going to pause my video for a moment. I'm going to create some different arrays. It won't seem like a lot of time to you because I'm just going to come right back into it, but you're going to suddenly see a bunch of different arrays up on the screen. All right, so don't be shocked when you see that. Okay, boys and girls, so I have created some different arrangements of tables that all have a perimeter of 20 units. Now here I have 3 different arrays that I came up with, and here I have 2 more. So I came up with a total of 5 different arrangements. I asked you to come up with 3, so hopefully you were able to do that. Okay, so I'm going to go through and we're just going to kind of count it out and make sure that I did this correctly to begin with, and that you can see that they all in fact have a perimeter of 20. Okay, so I am going to really quickly erase all this from before. Okay, so if we look at this blue array that I came up with, if I count the sides, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 people can sit on this side. So if 9 can sit on the top part, that means that 9 can also sit down here. And then 1 person can sit on this end, and 1 person can sit on this end. So if I count that out, if I were to count 9 plus 1 plus 9 plus 1, I remember I can also write an addition problem. So I can write 9 plus 1 plus 9 plus 1. Well, I know 9 and 1 is 10, and another 9 and 1 is 10. So that would be 20. Okay, so that one has a perimeter of 20 that can sit around it. All right, now the purple one, let's take a look at that one. I'm going to change colors just so we don't get our dimensions mixed up. So let's see, in this side we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 people can sit on this side. So that means the opposite side is the same on a rectangle. So this side is also 8 people. And then I have 1, 2 on this side. So then I have 2 on this side as well. So I could count each and every individual side, or I could do an addition problem. So I'm going to do 8 plus 2, so 8 plus 2 plus the other 8 and 2. Once again, I know 8 and 2 is 10, plus another 8 and 2 is 10, so that gives me a total perimeter of 20. All right, so there's another arrangement. We take a look at the orange table arrangement I came up with. Let's see, on this side I have 1, 2, 3, 4, 5. Let's see, we got 1, 2, 3, 4, 5. So this side is 5. So that means the bottom is 5 and this is 5. So this is a perfect square because it's a 5 by 5. So if I wanted to find the perimeter of this shape, I could go 5 plus 5 plus 5 plus 5. Write that down here. 5 plus 5 plus 5 plus 5. So another way we could kind of write that is 5 times 4. So when you have a square where all the sides are congruent, they're all the same length, to find the perimeter, you can actually just find the dimension of the length of one side and then multiply it by 4. So if I do 5 times 4, 5, 10, 15, 20, and once again have a perimeter of 20. All right, let's take a look at my other two that I created. So if we take a look at the yellow one, all right, blue again, because we're on a different page. We have 1, 3, 4, 5, 6, 7. This side is 7. And then I have 1, 2, 3. So the opposite side is 3. So to find the perimeter, I can go 7 plus 3 plus 7 plus 3. Once again, I know 7 and 3 is 10, plus another 7 and 3 is 10, so my total is 20. All right, if we look at the last one, we have my red one. My dimensions are 1, 2, 3, 4, 5, 6. So this side is 6. Then 1, 2, 3, 4. So to find the area, I can go 6 plus 4 plus 6 plus 4. 6 and 4 once again is 10, and 10 and 10 is 20. So all 5 of my arrangements, you have a perimeter of 20. So hopefully you were able to come up with 3 different arrangements out of the 5. Okay, now one thing that I'm hoping you're noticing is that even though all of these rectangles have the same perimeter, they have very different areas. So we're actually going to take a moment just to look at that. So if I go back to this document, I have a chart here. Now it kind of looks like a ratio table. It's more of an organizational chart that we're going to take a moment. We're going to kind of compare some different things about the different rectangles that I created, all that have a perimeter of 20. I'm going to be writing down what the width of that rectangle is, the length of it, or sometimes we might even say like the height, or the width and the height. And then we're going to write down the perimeter for each one and then the area for each one. So I'm going to kind of be jumping back and forth again. So I'm going to start with the blue one. We had a height of 1 and a length of 9. So on my chart, I'm going to put down, actually, let's, just trying to think of how I want to do this. We're going to say we'll say a width of 9 and a length, or I'm sorry, a width of 1 and a length of 9. So we have 1 by 9. We said the perimeter was 20 units. What would the area be? If I go back to this and I were to actually count all the different squares in it, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way to think of that is, remember, to find the area, we can do multiplication. It's a 1 by 9 array. So I could think of it as 9 times 1. And what is 9 times 1? It is 9. So my area is 9 square units. Okay, I'm going to just draw a line so we don't get mixed up. Let's look at my next one. My purple one, we said it had a height of 2 and a length of 8. Keep clicking the wrong thing. So we had a width or a height of 2 and a length of 8. The perimeter was still 20 units. And my area, I can do 2 times 8, and that used 16 square units. All right. My next one was, I'm actually going to come back to the orange one in a moment. I'm going to look at the yellow one next. We had a height of 3 and a length of 7. So height of 3 and a length of 7. We said the perimeter was 20 units. To find the area, 3 times 7 is 21 square units. All right. We'll look at the red one next. We had a height of 4 or width of 4 and a length of 6. My perimeter was 20 units. And 4 times 6 to find my area is 24 square units. And lastly, number 5. I'm going to go back to my orange one. We said it had a height of 5 and a width or a length of 5. 5 and 5. We said the area, I'm sorry, the perimeter was 20 units. Find the area. I do 5 times 5 equals 25 square units. All right. Now, if I take a look at this chart, is there anything you're noticing about the different dimensions of the rectangles we created? Are you noticing anything about the perimeter? Are you noticing anything about the area? Well, I'm noticing that for all of them, as we said before, all of them have a perimeter of 20 units. So that stayed the same. But the areas are all very, very different. We have one that was 9. We have 16, a 21, a 24, and a 25. There doesn't really seem to be a pattern going on there because it's almost, from 9 to 16, we only went up 7 tiles. And then from here to here, we went up, 5 tiles, and then we went up 3, and then we went up 1. So there's not a pattern happening in the area. It's just the way it ended up being because we kept adding more and more tiles to our arrays. But look at the pattern that's happening with the dimensions. I started with the width of 1, and or the height of 1, and every time I changed the height, I was going up by 1. What was happening to the length? The length was going down by 1 until they ended up with that perfect square. Okay, so we were kind of taking a tile away from one side. It's almost like with this one, if I were to think about this, if I were to move this down here and create a second row, like what that's turning into the purple one. So the area would definitely have to change because I would have to add more blue tiles to fill in that rectangle, but the outside border wouldn't change very much. Okay, so one thing I want you guys to be aware of is that when it comes to perimeter, we can have lots of different quadrilaterals that have the same perimeter, but they could have very, very different areas. And remember, area is the amount of space inside of something. So that the perimeter and areas don't always match up to each other. All right. So one of your assignment for today, guys, is to do a workbook. Your yellow workbook page is page 205. Now, one thing I wanted to point out to you guys really quick is in the directions. It says Rodney Rabbit invited 17 of his pals over to play board games. Use tiles and red linear units to build as many different rectangular arrays as you can. So it's not just building one or drawing one, it's drawing as many as you can. And I'm going to give you a hint. There are about, I believe, 3 more arrays that you can create. So they gave you one example. And you did something very similar to this yesterday in your in one of your workbooks. But you're going to be creating an array that has a perimeter of 18. Okay, so we've done it with 10, we've done it with 20. On your workbook page yesterday, I think you were doing 16. Today you're doing 18. And there are 3 more possibilities that you can fill in on this chart. Number 2 says record the dimensions, the perimeter and area of each of the rectangular arrays you built on the chart below. So just like they did with this example, they said the width was 1, so they wrote a 1 here. Then they wrote the length was 8. And then they figured out what the perimeter was, and then they figured out what the area was. So just what I just did now in our activity, you're going to be doing something very similar, but you're going to be doing it on this chart with a different perimeter. Now, they did give you 4 more spots to fill this in. If you can figure out a bonus one, that's fine. But like I said, there should be 3 more possibilities that you're coming up with. Okay. All right, the last thing we need to do for our lesson is go over the questions that I gave you at the beginning of our lesson. So if we go back and we identify these 2 quadrilaterals, we have this one right here is a square, and this one here is a parallelogram. As my students know, this is one of those words that I never know if I'm spelling correctly. I'm always like, where are the double L's? Where do they go? Okay, so for similarities, things that I found they have in common. Let's see, I was saying that one thing that they have in common is that they both have, well, they both have 4 sides. They both have 2 pairs of parallel lines. They both have 4 vertices. And they're both closed figures. Meaning, remember, that means that they don't have any, there's not like an opening. If this were like a box, nothing would be able to get in. Okay, so those are some similarities I found. Those, I know I said only find 2, I found 4, but check and see if you have 2 from that list. All right, and then for differences, I actually only really found 2 differences between the square and the parallelogram. One difference that I found is that a square has 4 congruent lines, meaning they're all the same length, and a parallelogram doesn't. Because if we look at that parallelogram, we have 2 sides that are shorter. The height is shorter than the width. Okay, and another difference I found is that a square has 4 right angles, and the parallelogram has 2 acute angles and 2 obtuse angles. Remember, a right angle is one that is like a perfect corner, so you can use like a corner of a sheet of paper or a Post-it to find out. And a square has 4 of those. An obtuse angle, like this parallelogram has, is bigger than a right angle, so this one has 2 of them. And an acute angle is 2. Those are smaller than right angles, and this parallelogram has 2 of them as well. All right, so if we take a look at our story problem, it says Emery was making dessert for his party. He made 9 dozen chocolate chip cookies, 4 dozen blueberry pies, and 8 dozen brownies. How many desserts did he make in all? Well, when I'm looking at this problem, the first thing I realize is I need to figure out what is a dozen, because that word pops up a bunch of times. So if you think about like eggs, we usually, when we go to the store, we usually buy a dozen eggs, and a dozen equals 12. Okay, so if he made 9 dozen cookies, that means he made, or 9 dozen cookies, that means he made 12 cookies 9 times. So I'm going to have a multiplication problem there. So that first part, I'm going to be solving 9 times 12. That's not the only thing Emery made for his party. He also made 4 dozen blueberry pies. So he made a dozen pies 4 times. And then he also made 8 dozen brownies. So I'm going to also do 8 times 12. Now, if I was to write a nice fancy equation for this, I'm going to put some parentheses, and I'm going to have to figure out all these multiplication problems, and then I'm going to have to add them together. Okay? So first, to solve 9 times 12. Now, there's lots of different ways that you could solve these problems. Now, one thing I like to do whenever I'm multiplying by 9 is I like to actually multiply by 10. So if I do 10 times 12, I'd get 120. And then I'm going to take away one group of 12 because I was only supposed to use 9 groups and I used 10 groups. So I have one group too many. So I'm going to subtract that. And if I do 120 minus 12, I'm going to get 108. So Emery made 108 cookies. Okay. Then I need to figure out 4 times 12. Well, when I multiply by 4, I like to do double doubles. So I'm going to double 12 and get 24. And then I'm going to double 24 and get 48. Because I did 2 groups of 4. I doubled and then I doubled. So he made 48 pies. That's a lot of pie. But he did invite a lot of people to his party, didn't he? All right, to do 8 times 12, I'm going to do this one slightly different. Now, I could do a double, double, double strategy, or I could think of it as, I've done this before with you guys. I'm going to split up this 12 into 2 groups. I'm going to split it up into a 10 and do a 2. I'm going to do 10 times 8, and then I'm going to do 2 times 8. And 10 times 8 is 80, and 2 times 8 is 16. And if I add those 2 together, I get 96. All right, so he made 108 cookies, 48 pies, and 96 brownies. All right, I need to ultimately figure out how many desserts did he make in all, so now I need to add all the 3 things up. Now, I'm not quite sure what strategy you came up with, but just to speed things along, I'll just give us the answer now. So hopefully your answer matches. Altogether, he made 252 desserts. Make sure you're labeling your answers. All right. So thanks for sticking with this lesson, guys. Good luck with finding the perimeter of your different rectangles for your workbook page, and have a great weekend. We will see you next week, Tuesday, for our next math lesson. All right, bye guys.